Let's get going. Welcome, everybody, to episode 15 of Tech Talk Tuesday, Season 2. And all the other episodes of Tech Talk are available on YouTube. The Baseline channel is Baseline Web Training, all word on YouTube. And you can find all of Season 1 there as well. And this is actually working out really well. We're getting lots of good feedback from you guys that you've watched old episodes, or you've been in the field, or you've had a client or customer that needs to know something. So just remember that these videos are there. If you're with us and you work for a distributor, you can point your customers, either end users or contractors, to these videos to help them work through a lot of their how-to questions. So some quick introductions. I'm Andy Humphrey, Irrigation Technology Consultant for Baseline. We have Dan Conger, our training manager, Chris Wright, VP of Sales. And the topic for today is zone concurrency, which I'll preface, AKA running multiple zones at one time, how to do it, the power of it, why you'd want to do it, and all of the above. So with that, Dan, let's kick it off.
Beautiful, beautiful. Well, the timeliness of this is like perfect, because I had a conversation with a customer in this last week. I was helping them out with a little bit of system information, and they ran into exactly this issue. And I said, if you ran multiple zones at once, if you increased your zone concurrency, this would solve at least this portion of the problem for you. So I think let's talk about the why a little bit more. So I think there are times when people have a narrow water window, when they have a limited time in which to water. Zone concurrency is really important, or multiple zones at once. If you ever run across that message that says program overrun, we talked about in error messages, is essentially when a program was running and then another start time came along, or you ran out of watering time, and then a pump that cycles off and on. Right? Those are all problems. Well, let me rephrase that. A pump that cycles off and on doesn't last as long as a pump that runs at a constant flow. So I think we can address all three of those when we can run multiple zones at once.
Yeah. And the list can get quite long.
Yeah.
There's
many
reasons.
And as I think about it, it always comes back to what we've talked about in the past, but just to reiterate, our real limiting factors on getting irrigation completed is the size of our water source or our main line, how much flow is available, and what that water window available is, right? So depending on what your flow availability is, you want to make sure that you are running as much as possible at one time so that you can get done with your watering in a timely manner.
Yeah. And so when it comes to concurrent zones, or how many zones you can run at once, there are two limiting factors to increase concurrency. And one is the hydraulic capacity. So let's take full advantage of whatever size pipe or water source we have. Let's push as much water as hydraulically that is safe to do that through, right? We don't want to be reckless with our velocities.
And what does that mean exactly, Dan? Can you just make that a little bit more tangible?
Sure.
What does the hydraulic capacity of a system mean?
So each individual pipe or each individual water source has a finite limit. There's physics. It's just physics. And you could shove only so much water through a 2-inch pipe or a 3-inch pipe before you start running into friction loss, and which means you lower your pressure, or high velocities, high speeds. And high velocity is related to friction loss, but it's also can result in water hammer and undesirable pressure and damage issues. So that's that. There's a threshold for each pipe and each material. And since we're talking about it, let me show you.
That's in terms of gallons per minute, right? So that's what. It's gallons per minute is the number.
That's right. Yeah. So for velocities, right? The standard in the industry for velocity through pipe is 5 feet per second. Right.
Right. So I've got a pressure loss chart here. That's what's kind of nice about these is every major manufacturer is putting them in the back of their catalog, but you can also get them from it's the industry standards. And this is a friction loss chart for class 200 PVC pipes. So it's very specific for the material. Here's another one for Schedule 40 steel and another one for copper. So different materials have that. You can kind of see this shaded area is outside that 5 feet per second. That's at a higher speed or higher velocity than is recommended. So I can trace down a 2-inch pipe, and I can see cross-reference the capacity that can carry. So a 2-inch can carry, looks like about 50 gallons a minute, 2-inch class. 2-inch schedule 40 is going to be less because it's different wall. So this chart we'll reference this again in a little bit, but this is kind of the limiting factor on the material and the pipe that's in there.
Yep. Let me get you off spotlight. And we're fully aware that probably at least half of you, or if not all of you on this call right here, right now, may know this. Just as a reminder, we do record these and put them on YouTube for people that are new, may not know this. So sometimes we're going to talk about things that are basic because there is an audience out there that this is helpful. And it is kind of the foundation to the settings that we're going to discuss.
So there's the hydraulic limit to increasing zones. And then the other limit is the electrical limit, is how much can your wiring system handle? How much can your transformer handle? And we've got those two limits that we need to address today. So I think first we're going to address the hydraulic, and then we'll come back to the electrical side. So let me share my screen, and I will show you. We've already got Base Manager open, and I'm going to jump right into schedule. So we're going to look at this program number 1, your spring program, because this is Andy's controller. We're taking a look at his demo controller.
It's not my real controller, but it's the one that we use to play around. It's the sandbox.
Exactly. So in the schedules tab, we're gonna take a look at the concurrency. So let's go to edit, so I can see all the full things. We're gonna jump past the zones, and then we've got your water window. But here, this program concurrent zones and controller, this section is really what I want to look at. So right now, this program is set up to run 2 zones at one time out of this program. So that means that there's only 5 zones in there. That means that zone 1 and zone 3 could run, and then zone 4 and zone 5 could run. So I take it back, there's only 4 zones. So that means 2 zones could run at a time. Now we could change that, and the default is just 1 and 1. And I think that's where people are so used to, stacking programs and stacking zones that it just runs 1 by 1 by 1 by 1. Well, that's where people get jammed up with running out of watering time or having their pumps cycle off and on, is because they are running 1 at a time. So, Andy, do you know, since this is a sandbox, you don't really probably know how you got to that. How can I run 2 zones at a time for this program?
Well, so the sandbox is there because sometimes we have clients that want to run a scenario. So in this case, this controller is fully loaded with all this kind of stuff so that we can just run a scenario and make sure that we know how to set the controller up the way that the way that we're intending to on the project. So in this case, that was there because they wanted to create that scenario where maybe programs 1 and 4 and 6 all run together, but we're containing the number of zones each program. So anyway, there is a reason why it wasn't just.
Sure. Okay. So now what you might know, if you're the operator of this system, you might know that all of these zones, zones 1 through 5, are relatively low flow, and you've turned on 2 zones at a time, and you haven't had a problem with your pressure dropping. I think that is the easiest way to get into this, right? It's not particularly sophisticated, but if you've turned on 2 zones in this grouping, in this program, and they've run fine, then you can run 2 at a time.
Yeah. And that's a eyes on sight, right?
Yeah.
You've seen those zones operate at the same time, and pressure's good. You're getting the coverage that's desired. And, it's a visual indication.
Right. And I think that experience, I don't want to discount experience. I mean, I'm more that nerdy side, and I like busting out those charts, which is the other way of doing it. But I think the eyes on site and is really valid in that experience, to know that you could run 3 drip zones at a time with your main line. Well, I mean, how do you know, right? You turn them on and you could check the pressure, or you could measure the pressure. So you might find that, in fact, you could run 4 at a time. Maybe we could run all 4 of these zones at once. So what we've said with program concurrent zones is the program can run 4 zones at a time. Well, this controller concurrent zone down here says that we could run 6 zones at a time for the entire controller. So those 2 remaining zones would come from another program, one or 2 other programs, kind of depending.
Okay, so what if you left concurrent zones at 2? You said 4 for the program, but 2 for the controller. What's the behavior?
I'm not even sure what it would do if you hit save. Does it just default it?
I think it's going to. Ooh, I like Chris's quiz today. We could start a list of Chris's quiz. What kind of curveball is he going to throw you today?
Click save and see what it does.
I think it's going to default to two at a time because that's the most we've told it.
It either will or it won't. But what Chris is hinting at is it cannot run more than 2 because that's the value for the whole controller.
That's right.
What I don't know is whether it can actually hold a number 4 or whether it'll.
I know. So click save and let's see what it does.
I've seen it, and I know how it's going to save it. So okay, so then we'll go back into the program, and
dun dun dun.
Yep. Okay, so it does save a larger number for the program and a smaller.
Is that what you were expecting, Conger?
It actually was because I saw 4. I saw 4 and 1 when I was doing my homework for this.
It's actually a pretty good point, though, Dan, because a user then may call support and say, "I told the controller to run 4 in this program. Why isn't it running 4?"
Because you put a smaller number of 2. Yeah. So, reality, I'd want to put 4 and 4, but I think the other one is another way of doing this is. Maybe I'm going to do 4 and 1. So I'm going to say each program could run 1 at a time. So that would mean 1 from program 1, 1 from program 2, 1 from program 3, 1 from program 4, or any combination thereof, right? So now what that means though is you need to kind of understand your system a little bit. You need to understand the basic capacity of your main line, the basic capacity or the basic flow numbers for your system. Although you could do this even without it. If you didn't have a flow meter, you could still do this.
Yeah, without a flow meter, this is a great way to balance the hydraulics on the site. You've got 99 programs available, right? So look at the balancing across the site and say, okay, I want these zones over here to run separate from over here on different programs, but you can set it up so it'll run 1 at a time out of each one of those programs up to a total of 4 or whatever and balance your hydraulics without a flow.
Because you might have another spring program that's the same type of zones. It might be rotor zones in spring program A and spring program B, but these are the big rotors and the other one are the small rotors. And then you're going to change the concurrency on that just based off of the size of the heads. So, yeah.
And it's a very common question, when someone's out in the field and they've called me in the past, the question is, how do I get the controller to run multiple zones at one time? They may not have a flow meter. And if they do, they haven't done a learn flow. So it's not about flow. They know which zones they want to run together, or they know it doesn't matter. Any 2 zones can always run on this system. Sometimes it's just very simplistic like that, but they want to know how to go in and set that up.
Beautiful.
So we've had a couple of questions come in that are good. Mr. Glazner, we kind of addressed it already. How can I specify which zones can run concurrently? And how can I specify which cannot? So it's based on that kind of balancing and separate programs and saying 1 at a time out of this program to make up a total of 4 across a particular area. So we kind of addressed that already. And then Craig Stockhouse wants to know, what about program priority affecting watering window by not allowing multiple programs to run at once?
This is a great question.
That is a great
we learned
question.
something not too recently or fairly recently that, only priority 1 runs by itself.
The highest priority.
Right.
If you have all of your programs set to priority 1, it's going to essentially stack them.
Right.
But if you have everything set at 2, but have 1 program set at priority 1, then that priority 1 program is going to trump the priority 2 programs, and it'll run that program alone for whatever the concurrency setting is for that program, regardless of the controller concurrency, because that program has priority to start and finish before anything else does.
So to reiterate, Chris, you're saying that a priority one program ignores concurrency and says, nope, I run all by myself. Even if you said,
it'll ignore the controller concurrency, right? Unless the, program concurrency for that prioritized program matches the controller concurrency.
Right. Beautiful.
Yeah. Okay. So they're kind of like those two settings. In my mind, I think of them as containers. So you've got a big container, which is the controller, and the big container holds smaller individual containers, which are the programs. And then inside the program containers are, the zones.
Yep.
Cool. So I wanted to take a look at, I'm going to up our game a little bit here. And for this one, I'm going to go to the flow setup and then go to main lines.
Okay.
And on main lines, let's jump into that. Give us a moment to load. And on main lines, we're going to turn a lot over to, we're going to turn 90% of this over to the controller. So Andy's already done some editing on this one. So he has the design flow set to 380 GPM. So oh my goodness, dude, what size main line is that?
It is a big site. I think it's maybe a 6-inch.
That's a 6-inch. Yeah. So a 6-inch mainline can carry 380 GPM. This number that you got is absolutely critical that you get this right. And that's where we're going to reference this chart or something like that to get that number right. And the reason that number is absolutely critical to get right, and this is, although we only need to get it right once, is you've selected right here, manage by flow. So what manage by flow will do is we'll determine zone concurrency based off of that design flow you put in there. You said 380. So we'll find any combination of zones up to, but not exceeding 380 GPM. So a 150, and an 80, or, you do the math, right? You figure out any combinations of those up to 380 GPM, puzzle piece those flows together. I think managed by flow is probably the single most powerful thing in
it's kind of what runs, if we want to call the watering algorithm inside the 3200, it's like all built around this.
Yeah.
Yeah. And using real-time flow data, right?
Yep.
Not math flow,
nice.
Real-time flow, right?
So
it can be random based on those different priorities that you may have set up, or the different hydraulic makeup of a program, so that it'll manage it to that 380 gallons per minute.
Yeah. So, because like if we had a grouping of zones that faulted out because of a wire problem, that's real time, right? It'll recalculate that on the fly rather than saying, no, we're just going to have 4 hours where nothing runs. And
let's just have a reminder of what this doesn't mean. What this doesn't mean is if you set concurrency to 1, it will not run 380 gallons a minute. If concurrency is set to 1, it runs 1.
Yep.
So
runs whatever's least restrictive. Either 380 is the restrictive value, or zone concurrency is the restricted value.
Yep, that's a great point.
So thank you, Andy, for this one. To take full advantage of this, we're going to come back into schedules, and I need to crank this up. So I'm going to go with
if you're doing managed by flow, you might as well give it every opportunity that there is, unless there's something else you're considering. Open it wide up, because 380 is the limit.
Yep.
Yeah,
exactly.
So now with a 15 zones in the program, 15 zones for the controller, cranking that up to 15. And the reason I pick 15 is because this is a 2-wire system. So 2-wire systems can run 15 zones concurrent based off of the size of the transformer in a single controller. And I'm laying the groundwork for a few things that are going to come up in a few minutes. A single controller with one transformer can run 15 zones concurrent.
On 2-wire.
On 2-wire.
Dan, every wire. This is baseline. What do you mean?
Well, so let me stop share and let's take a look at this. It's amazing how this is all interconnected, isn't it? Okay, so here I've got on a 2-wire, but on a conventional wire system, it's a little bit different. So a 2-wire system, we can run 15 zones spread out over the entire system, but a conventional wire system, I've got a 24 zone power bicoder. So I got essentially out of this bank of 12 zone bicoder here, and this 12 zone bicoder here, I can run 2 zones on concurrent anywhere off of this bank and another 2. So this board can run 4 zones concurrent spread out over this one, 2 and 2. So sometimes we find that people, they end up with the 4 that they would run concurrent all on this side, and maybe they need to move the wires around a little bit, but conventional wire is a reduced number. It's not quite as many as 2-wire.
Yep. And we have seen, if you want to, let's say you only have 12 zones, but you want to run 6 at the same time, you would need to purchase a 36 zone controller and move your wires, across those terminals so that 2 zones from each 12 bank can operate together. And then you would have a total of 6 concurrent on conventional.
Right. Because you can fit 48 zones of conventional wire into a single X cabinet. Beyond that, you're going to need an additional X cabinet. So nice.
And it does come up, and there's nothing wrong with that. There's no reason you can't have empty zones. There's nothing wrong with that. And you can just unassign them from the controller. So they're invisible, basically.
Mm-hmm. Now,
so let me ask this question too, since we're on the subject of moving wires so that we can optimize that concurrency. If I have 4 zones that I want to run at the same time on those first 12 posts, and I have to move 2 of them to the second 12 posts, do I have to change the zone number?
Ooh, no, you don't need to change the zone number because the serial number will change, but the zone number can stay the same.
Correct.
You just need to unassign and reassign. Just go back into that search and assign process. I'd recommend just unassigning all of it and then putting it back in the order that you want. But the physical connection happens to be on that other board.
Yep.
It's one of the few times that you need to move the physical connection when you want to do it. Normally you don't. You would just leave them connected to the same terminal. Nice. So then one other thing to show you on this one, which before we leave the screen share is, so I cranked this up to 15. So we said here it would pull up to 380 GPM and up never exceed 380, and also up to 15 zones, but never exceed 15. So any combination of no more than 15 zones, no more than 380 GPM. So lots of manipulation a lot of rope we've given the system to run it, and it will definitely solve that water window, the program overrun, that cycling. It'll solve that issue pretty dramatically.
And one quick reminder too, if you have a zone that does not have a learn flow, it runs it by itself. So keep that in mind. If you've added a new zone sometime in the future, or you haven't run one yet, it doesn't know what to do with it. So that runs that rogue zone, if you will, by itself.
Good point. This is all dependent on learn by flow and a flow sensor, flow meter. Yeah. Now, interesting. There we go. So if you look on Andy's controller, well, I can actually crank up zone concurrency quite high. I could crank up controller concurrency to 99 different zones.
Dang.
So let's talk about that, because I think that brings us into a whole nother world of so first of all, I want to see a system that could hydraulically run 99 zones at a time, which would be kind of cool.
That's the challenge, guys. Find us a new construction project where we can prove if this stuff works.
Yeah.
So it's possible if you've got a 8-inch main line or something large and it's all drip, it's possible to run a bunch of zones at one time.
Sure.
Dan, how do we actually do that? There's not enough power in a transformer to happen. So how does that work?
Did you catch when I was carefully chose my words in the beginning? I said it's based off of a single controller with its transformer can run 15 zones at a time on 2-wire. Well, a substation is its own box with its own transformer. I get another 15 zones. And a second substation, then we can run 8 substations from a single 3200. There we go. We could crank that way up. So that is probably the easiest way to do it is add a substation to increase zone concurrency to what your hydraulics could handle. So now you might not need a substation for the physical, or the other one is another controller, another box with its own transformer and another 5200 or powered by coder inside of it. Either way, which is really what the substation is, right?
Yeah.
Yep. Exactly.
So,
Okay. So just to be clear, all right, we spoke to it kind of conceptually, but the substation is an extension of the programming and operational power of the 3200, right?
Yep.
Absolutely.
So each box that has its own transformer is capable of operating 15 solenoids at a time on 2-wire.
Correct.
So that is why we're able to increase the zone concurrency on a 3200 beyond 15 when we've got substations as part of the configuration because they have their own transformer.
Right.
So here's the quick math. How many, a 3200 plus how many substations maxes out that concurrency?
I think it's,
I just did the math because I didn't know I had to use my calculator.
so you got 15 on the 3200. So it's four substations.
So it's 6.6 transformers or 7 transformers. That would be one controller and 6 substations maxes out.
Okay. I did.
Okay. Quick math. Yep. All right. Nice. So we hit the substation. So Craig Stockhouse brought in another great question. What about water windows on sites with multiple controllers with one POC?
Yeah, we got to level up in that case.
Right. So what's required there?
Got to have a flow station for that one. Baby.
Yeah. It's managed exactly the same way. It's just being managed by the flow station that knows the design flow of the whole hydraulic system and then is allocating water to those controllers that have programs that need to run based on the design flow of the water source that the flow station is managing.
Yep. Right. So that decision gets pushed from the 3200 up to the flow station because now there's multiple controllers. So you can do more than that. You just have to, level up the control system and add that next level capability.
Yep. Absolutely. Nice. So great question. All right. Very good. What else you got there, Mr. Conger?
Well, let's jump back into screen share. Looks like I got just a couple of minutes here. I wanted to show you what it looks like at the controller. Cool. So I'm going to go to live view. So you could do this same work instead of doing it in Base Manager. You could do it through live view. So let's take a look at program concurrency, and that's in programs. So live view is that it's just another way of looking at what's going on with the controller. So here under programs and then concurrent zone setup, and I always got to remember, right, that you arrow through this just like you would if you're at the controller.
And remember, the best way to do this is to count boxes and hit the button that number of times.
Yes.
Oh yeah, I know. That's what
you will. Yeah, that's what you need to do.
Yeah. Dan overshot it.
I know. That's why support just kicks my butt on this. Yeah. Because there's that delay that's built in there. So here we can see each program. We can right now, program 1 is set to 4 concurrent zones for the program, and it's still showing that we have the total allowed for the controller set at 2. So it will limit to the 2. So this is program and controller concurrency.
Yep. And that bottom box, total allowed, is often missed. Mm-hmm. That's a cause of common questions and calls. They miss that.
So the other thing that's kind of interesting or worth pointing out is, so we can change program concurrency for each individual program, but total controller concurrency, there's only one, because there's only one setting. Once if we change it in Base Manager for one program, total controller changes for everybody, right? If I change it to 15, everybody, it'll reflect that way in program. Mm-hmm. So that's on here, and then on the flow setup is where we're going to get to the manage by flow and the mainline setup. So let's open that up. So on mainline setup,
and one thing we didn't touch on, manage by flow. well, correct me if I'm wrong. This could be an assumption I had that's not true, but I think it is. Managed by flow works whether you're using a flow sensor or not. You can enter the gallons per minute for every zone and do a calculated flow management.
Absolutely. Yeah.
And that sometimes is a good way too, because usually you have a gut feeling like, hey, that's a 15 gallon a minute zone. You know what? Maybe it's 17.5, but you know what it is pretty close. So if you just go through the process of entering a flow value for every zone, enter your water source flow value, then activate managed by flow, it'll use those calculated flows to do the hard math for you.
Yeah. So for example, zone 2 doesn't have a design flow. It hasn't learned flow. So we could manually enter that one, and by either counting heads or reading the water meter or whatever, without having a flow sensor or flow meter. But all these others have been populated from learned flow. Beautiful.
All right. So you're 1 minute over time. What else did you need to show on the main lines? Anything? Or did you?
I think I covered what I needed to cover.
We got it. Okay.
Yep.
All right. Very good. Well, that puts us at the bottom of the hour. So we got to let these guys get back to work. I think we answered all the questions that came in. Good questions. We appreciate your participation this week. Always good to have you out and learning more about baseline technology. Please make an effort to share a link or talk about Tech Talk Tuesday with colleagues that you work with to get them to participate too. Again, we're working together to flatten the support curve and give you as much content as possible to help you when you are faced with an issue that you need help with in the field. Reference the YouTube channel, watch the recordings, and we're here to expand your knowledge base on how to use and implement baseline technology. So we appreciate it. Go out, have a great week, work hard, be safe, and we will see you again a week from today.
Next week.
Same time.
Thanks, guys. See you later.
All right.
See y'all then. Bye.
Bye-bye.